Hi all of you. I am Steven from Aero Department. Today I am here about Tech Talk presentation. My topic is plastics in aircraft electricity. And let's go into the topic. There are majorly five types of plastic used in the aerospace industry. Plastic as a major component in the aerospace industry since 1970. They reduce the weight of the aircraft and improve fuel efficiency. When it comes to military aircraft, they help extend flight range with help jets evade radar detection. Components for propulsion and navigational functions, structural elements and interior components are all made out of plastic. Uh, Plastic has several advantages which make them an ideal choice in the aerospace industry. First one, lightweight, corrosion resistance, impact resistance, chemical resistance, durable. Let us look at five types of plastic used in the aerospace industry. First one, polyether ether ketone is a preferred polymer in the aerospace industry. It is used in conditions where it may be exposed to low temperatures and atmospheric particles. Its applications can be found in pump gears and valve seats. It can withstand large doses of radiation and has great resistance to hydrolysis. This means it can be exposed to high pressures of water and steam without degrading. Furthermore, it exhibits great thermal and mechanical properties that include low flammability and creep resistance. Polyether ether ketone is also known as PEK, is a colorless and organic thermoplastic polymer in the polyaryl ether ketone is nothing but PAEK family. These both are like family and used in engineering applications. The polymer was first developed in November in 1978, later being introduced to the market by Victrex PLC. Then Imperial Chemical Industries is nothing but ICI in the early 1980s. Next, PEK polymers are ability obtained by step growth polymerization by the dialkylation of bisphenolate salts, and also typical is a reaction of 4 comma 4 difluorobenzophenone with the disodium salt of hydroquinone, which is generated in C2 by deprotonation with sodium carbonate. And here the reaction is conducted around 300 degrees Celsius in polar aprotic solvents such as diphenyl sulfone. And let's we go into the properties of PEK. PEK is a semi-crystalline thermoplastic with excellent mechanical and chemical resistance. Properties that are retained to high temperatures. These processing conditions used to mold PEK can influence the crystallinity and hence the chemical properties. Its Young modulus is 3.6 GPa and its test length strength is 90 to 100 MPa. Peak has a glass transition temperatures of around 143 degrees Celsius and 289 degrees Fahrenheit is nothing but, and melts around 343 degrees Celsius is nothing but 662 degrees Fahrenheit. The thermal condition conductivity increases nearly linearly with temperature between room temperatures and solidus temperature. It is highly resistant to thermal degradation as well as to attack by both organic and aqueous environments. It is attacked by halogens and strong Bronsted and Lewis acids as well as some halogenated compounds and aliphatic hydrocarbons at high temperature. And let's go into the applications of PEEK. PEEK is used to fabricate items for demanding applications, including bearing, piston parts, pumps, high performance liquid, chromatography columns, compressor plate valves, and electrical cable insulations. PK is used in medical implants used with a high resolution magnetic resonance imaging. MRI is nothing but magnetic resonance imaging for creating a partial replacement skull in neurosurgical applications. It is used in neurosurgical application, and it is one of the few plastics compatible with ultra high vacuum applications, which make it suitable for aerospace, automotive, teletronic, and chemical industries. And this application is used in bearings, in piston parts, pumps, chemical industries, and also in hospitals, in surgicals, and is also used in aerospace, automotive, teletronic. And PEK is used in spinal fusion devices and reinforcing rods. It is radioacid, but it is hydrophobic, causing it to not fully fuse with bone. PEEK seals and manifolds are commonly used in fluid applications. PEEK also performs well in high temperature applications, up to 500 degree Fahrenheit or 260 degrees Celsius. Because of this and its low thermal conductivity, it is also used in FFF, triple F printing to thermally separate the hot end from the cold end. And second one, thermosetting polyimide. Thermosetting polyimide makes for a great choice in various structural applications in the aerospace industries. It is used in aerospace industries for structural applications. It is used in insulators and electrical spacers for threaded nuts and other components. It has high resistance to chemicals and exhibits excellent mechanical properties also. The biggest advantages that thermosetting polymer offer is a high ductivity than ceramics and lower weight than metals. And thermosetting polymers have been widely used as matrix design in fiber reinforced composites for aerospace applications, owing to their high strength to weight ratio 1:2, excellent heat resistance and thermal stability, and excellent mechanical and dielectric. And the polymer performing process and characteristics. The polymer performs thermoset polymer. It can be remelted like thermoplastic, and it is cooled using it a chemical reaction or irradiation as the driving energy force. Before cutting, thermoset materials exist in a liquid or malleable form. The cutting process cross-links the resin, creating a stronger bond that holds the new solid material together. And the polymer performing process. Next, the final cured thermoset polymer has a higher melting point than the temperature used to create it. So it's impossible to remelt. A thermoset polymer will begin to decompose before reaching melting temperatures. Once formed, polymer offers thermal stability, mechanical strength, structural integrity, and chemical resistance. And next, third one, polyamide is nothing but PAI. PAI is performed over metal components in the aerospace industry. It is used in aerospace industry for metal components. Reasoning being it is resistance to most chemicals and radiation at room temperature, and is flame retardant. This doesn't give off smoke when burning. It doesn't give us smoke when burning. What's more, so superior mechanical strength and can return up to 500 degrees Fahrenheit. It is mostly used in chemical radiations and in aerospace industries components. And polymer amides are either thermosetting or thermoplastic. It is and Amorphous polymers that have expectational mechanical, thermal, and chemical resistance properties. Polyamide amides are used extensively as wire coating in making magnetic wire. They are prepared from isocyanates and TMA. TMA is nothing but trimalic acid and anhydride in N-methyl 2 ferrolidin NMB. A prominent distributor of polyamide amides is Solvay Specialty for Polymers, which uses the trademark Tylon. Pol- Polymer amides are either thermosetting or thermoplastic, and thermal and chemical resistant properties it has. And polyamide amides display a combination of properties from both polymers and polyamides, such as high strength, melt processability, clarification needed, expectational high heat capability, and both chemical resistance, citation needed. Polyamide amide polymers can be processed into a wide variety of forms from injection or compression, molded pots, and ignites to coating films, fibers, and adhesives. Generally, these articles reach their maximum properties with the subsequent thermal cure process, and it is a wide variety forms compression molded pots also. And let's we go into the fourth one. Polychloro trifluoroethylene is nothing but PCTFE. PCTFE makes for a great material for components that are used in or outside corrosive environments. It is used in or outside in environment of corrosions. It is a fluorochemical plastic with a blend of physical and mechanical properties. This makes it an APT choice for aerospace applications. In addition, it is chemical and fire resistant and a low moisture absorption. It can tolerate extreme temperatures ranging from minus 400 degree Fahrenheit to plus 400 degree Fahrenheit and exhibits great electrical properties. And in these fluorochemical plastics blend of physical and mechanical properties, and it is extreme temperature is minus 400 degree Fahrenheit to 400 degree plus 400 degree Fahrenheit. It is also choice for aerospace applications. And polychloro trifluoroethylene PCTFE TFE or PCTCE is a thermoplastic chlorofluoropolymer with the molecular formula CF2CCIF, where N is the number of monomers units in the polymer molecule. It is similar to polytetrafluoroethane. PDFE is nothing but expect that is a homopolymer of the monomer. Chloro trifluoroethylene is nothing but CTFE. Instead of tetrafluoroethylene, it has a lowest water vapor transmission rate of any plastic. And let's go into the properties of PCTFE. PCTFE has high tensile strength and good thermal characteristics, and it is non-flammable and its resistance is up to 175 degrees Celsius. It has a low coefficient of thermal expansion. The glass transition temperature Tg is around 45 degrees Celsius. PCTFE has one of the highest limiting oxygen index. LY is nothing but limiting oxygen index. It has a good chemical resistance, and it also exhibits properties like zero moisture absorption and non-wetting. PCTFE PCTFE is resistant to the attack by most chemicals and oxidizing agents. A property exhibited due to presence of high fluorine content. It exhibits in the presence of high fluorine content, and BCTFE exhibits a permanent dipole moment due to the asymmetry of its repeating units. This dipole moment is perpendicular to the carbon chain axis. And lastly, we go into the fifth one, polytetrafluoroethylene, PTFE. PTFE is used for insulating cables and marriage fires in an aircraft. It is a fluorocarbon polymer and is an electrical insulator. It has high tear resistance, low flammable, and can retain its properties in aerospace conditions. And these cables and mirrored wires is used in aircraft, and it is an electrical insulator, and it has high tear resistance, low flammability, and with their lightweight properties, resistance to corrosive materials, and high temperature. Plastic is an ideal choice for the aerospace industry. If you are in the aerospace industry, then Plastivision is a great platform for you to showcase your product range and network with industry professionals. Polytetrafluoroethylene, PTFE. PTFE is a synthetic fluoropolymer of tetrafluoroethylene that has numerous applications. The commonly known brand name is PTFE. Based composition is Teflon by Chemours, a spin form from DuPont, which originally discovered the compound in 1938. Fluorotet flu- Polytetrafluoroethylene is a fluorocarbon solid, and it is a high molecular weight polymer consisting only of carbon and fluorine. PTFE is hydrophobic, neither water non-water, containing substance weight PTFE. As fluorocarbons exhibits mitigated London dispersion forces due to the high electronegativity of fluorine. PTFE has one of the lowest coefficients of friction of any solids. Of any solids, polytetrafluoroethylene is used as non-stick coating of pans and other cookware. It is non-reactive partly because of the strength of carbon fluorine bonds, and so it is often used in containers and pipework for reactive and corrosive chemicals. Where used as a lubricant, PTFE reduces friction, wear and energy consumption and machinery. It is commonly used as a graft material in surgical interventions. It is also frequently employed as a coating on catheters. This interferes with the ability of bacteria and other infectious agents to adhere to catheters and cause hospital acquired infections. And also look this. Let's go into this picture. Take a minute. PTFE is often used to coat non-stick pans as it is hydrophobic and possesses fairly high heat resistance. Superior chemical and thermal properties. PTFE is often used as a gasket gasket material within industries that require resistance to aggressive chemicals such as pharmaceuticals, paracetamols, or chemical processing. However, until the 1990s, PTFE was not known to cross-link like an elastomer due to its chemical inertness. Therefore, it has no memory and is subject to creep. Because of the propensity to creep, the long-term performance of such seals is worse than for elastomers that exhibit zero or near zero levels of creep. In critical applications, bevel washers are often used to apply continuous force to PTFE gaskets, thereby ensuring a minimal loss of performance over the lifetime of the gasket. PTFE is a ultraviolet UV transparent polymer. However, when exposed to an excimer laser beam, its C value degrades due to heterogeneous photothermal effect. Okay, thank you for giving this opportunity.